darn it. I hate that. Okay. So, right. Yep. Okay. Well, yeah, here it is again. Find the z-score for 27. Find the z-score for 31. The value minus the mean divided by the standard deviation. Put them in, normal CDF of those two, and there you go. Sorry, if you're at home, it's just a very, very short explanation. And then same thing here. Gina found the z-score of 28.5. She put it in. It's less than, so it's everything less than that. Shade everything on the left side. Negative infinity to there. So normal CDF of -99 to 0.25. And then the last one, found the z-score for 30.2. 1.1, put it in, and it's more than. So more than is everything on the right side. Normal CDF of 1.1 to 70, because this out here is positive infinity, any large number, 0.1357. Okay, no worries. It'll be fine. If you have more questions, come into office hours. Okay. Now we're going to get into something a little bit trickier. How about Ashley? Go ahead and read.
Sometimes you will want to find a z-score where a certain percentage of the population lies above it or below it. In this case, you are given an area or percentage and want to find z. There are some situations where you are finding a z-score.
Great. Patrick, go ahead and read this part.
Find the z-score so that 98.87% of the area under the distribution curve lies to the left of it.
Keep going.
So 82.12% of the area under the distribution curve lies to the right of it. And only 10% of the population is greater than or equal to it, i.e. it's cut off at for the top 10%.
Right. So here, again, top 10%. 10% is in this other area here. This is 10% at the very top. You want to find the z-score that goes with it. So here, we're all trying to find these z-scores that go right here. This is the kind of the opposite of what we've been doing. Before, we've been feeding the calculator 2 z-scores, and it gives us an area. This is the opposite. We feed it the area, and it's going to give us a z-score. That's what we call an inverse. The inverse of addition is subtraction. It undoes it. The inverse of subtraction then would be addition. It undoes it. They undo each other. The inverse of multiplication is division. The inverse of normal CDF is something we call inverse norm, INV norm. So we're going to be looking at how to find these things, because often we do want to know, well, what's the cutoff? I need to be in the top 10%, right? If I want to get into UC Berkeley, I need to score in the top 10%. You need to know what the score needs to be, right? So this is some of the stuff that comes up in life. How do you do it? It's really simple. The same way you get normal CDF, it's the next one down. Second bars, the third one is inverse norm. Here's the thing. What you feed it is the area to the left of the z-score that you want. So, for example, inverse norm, 0.025, would give me a z-score of -1.96. So this area is 0.025. So if I do inverse 0.0125, it's going to spit out a z-score of -1.96. Now if I look at this area here, what's my lower z-score? Negative infinity. So if I do normal CDF of negative infinity, negative 83, comma, negative 1.96, I will get 0.025. This guy and that guy will be the same because they undo each other. Right? So inverse norm of 0.025 gives me this z-score. Normal CDF from negative infinity to that z-score is going to get me back to 0.025. Someone give me a number between a negative 2 and positive 2.
0.
What was that?
0.
Something more interesting than 0.
1.
1. Okay, fine. Marginally more interesting. One. Everybody find this area. From here to here. So negative infinity. So do normal CDF of negative infinity, whatever you pick, to 1. Give me like 6 decimal places. What the heck?
0.841344.
0.8. Everybody do it. 0.8 what?
841344.
Well, if you're rounding it, it's 4, 5.
Yeah, I'm just gonna. Well, yeah, give me plenty of decimals. Okay. So this equals 0.841344. Good.
Yep.
Now, everybody do inverse norm of 0.841344. And you darn well better get 1. Or something that rounds to 1.000. Everybody do it. You get it? Inverse norm?
I got like
Alright, so everybody got 1 or something really, really like 0.99999, yeah? Good. So that's the idea. They undo each other, right? If you do one thing to get to this guy, then if you do the opposite of him, you get back to what you started with. Make sense? So what you do is you feed it the area to the left of the z-score you want. And it will tell you what that z-score is. So you feed it the left area, so in your notes, right, using your TI calculator and inverse norm, right here, to find the z-score for an area to the left of a value in a normal curve. So you guys do lab problem 4. Find the area to the left. Here, I'll give you a little picture to help you out. So 82.12% is that on the left side or the right side? Left side of some z-score, and you're trying to find this guy right here, that z-score. That's what you're trying to figure out, what that z-score is. So you'll do inverse norm of the area on the left. If you have a fancy calculator, then you get a choice of left, right. In this case, you pick left. So inverse norm of what, guys? If I put in 82.12, that's going to be 8,212%. 0.8212. Find it, and I'll randomly call on somebody. Check with your neighbors. I'll randomly call on somebody in 15 seconds to give me the answer to this. Juan, you got it? Janessa, you got it? You guys?
1 and 10% watch is basically.
Okay, work on it.
It's negative. It's negative 1.28.
All right, I'll do it with you guys.
How did the other one?
Second, bars, down to inverse norm. Hit enter, and I want the area to the left, 0.8212. Enter. 0.9199, so 0.92. That's this z-score right here. Maybe I'll move this up a little bit so I have a little more room to write. 0.92. That's that z-score. So this is what we're looking for right there. Next one, next page, flip the page, there's more, there's 2 more on the page. This one is to the right. So we can sort that one out. 10% is in the greater section over here, 10%, upper 10%. You want to find this z-score right here, guys, at the bottom. Figure out what that z-score is. So take a minute, try to figure out that one.